So in this brief lesson, we're going to talk about adding very basic dynamic hairs to this character. He has very simple, just loosely uncropped dreadlocks on his hair. So we're going to use the Maya Unlimited hair system to add dynamic splines to this character rig. So here we want to make sure we're in the Dynamics module. And we have a couple of components here. One being a NURBS or a polygonal mesh, which is the rigged character. And the other component is a 1° NURB surface, which I'm calling the skull cap. And the reason I'm using this is it has nice parameterization. It's 0 to 1 with 8 and 6 spans in U and V. And since a NURB surface inherently has UV coordinates, I can sort of create a skull cap that will not render, but be driven by the polygonal mesh, the rigged surface, and just easily grow just sort of random hairs off of this using the UV parameterization. And it's a 1° NURB surface, so the CVs are just snapped onto the vertices. So when we use this polygonal mesh to drive it, that will be a very easy process without heavy calculation time. Okay, so to create the hairs, I'll select the skull cap and then select hair, create hair. Let's open the option box, reset the tool real quick. I'm going to grow just NURBS curves. If we recall, our NURBS skull cap is 8 and 6 spans in U and V. So we're going to half those values, 4 and 3. And I'll leave the points per hair and length as they are, since he has a fairly long hair here. If we had a very intricate hairdo, this is going to be fairly stiff on this guy. You might want to increase the points per hair. That will give you more resolution with which to do your solve and particularly your collisions. Let's hit the Create Hairs button. So you can see we have a few splines here, 12 to be exact. So the next thing we need to do, if we run the we hit the timeline here, we'll see the hairs, they flop down. It's not a bad start pose, but they go right through the face in some cases. If we hit that timeline again, you'll see some of the splines just go right through the face. There's no collision. So we need to use this polygonal mesh as a collision object for the hair system. So we can do that by first selecting the object that will collide with the hair system, shift selecting the hair system itself, and then selecting hair, make collide. So now when we hit the playback once again, see our simulation runs a little slower, but the splines are colliding with the polygonal mesh here. Okay, so hit escape, stop that. I'm going to load some animation onto this rig. Select the appropriate head joint here, and just file, import, select a animation file here. Okay. So the next step we need to do is I'm going to use this polygonal mesh to drive the NURBS skull cap. I'm going to do that by first selecting the skull cap and then shift selecting the polygonal mesh, switching back to the animation module. And I'm going to create a wrap deformer. So deform, create wrap. Let's open the option box. I'll reset this. I'm going to use max distance, and because the CVs of this 1 degree skull cap, NURB skull cap, are coincident with the vertices, we don't need a high max distance, which is the distance that the vertices of the polygonal mesh will reach out in order to figure out what it's deforming. So we'll set that to 0.1. And then rather than using faces, we're going to set this to points, since we're going to be driving these CVs with vertices and they share the same position. Let's hit create. If I select the skull cap again, and we can see it moves around fine with the NURBS mesh, or polygonal mesh. Okay. So now let's, we're going to do one more thing here. Set the timeline and see what we have here. Okay, the hair is resting. Okay, still have a lot of penetration here. We get one good thing about it. There's a point before the head starts rotating where the hair, these dreadlocks, drape down into a relaxed position. Instead of this spiky straight hair look here, I'm going to let the simulation relax the hair, stop the simulation, and then use that relaxed position as a new start position for the hair system. So we'll activate the timeline. Okay, that looks pretty good right there. Oh, let's back up again. Okay. So this will be our start position. Once again, this is fairly rough. Actually, I'm going to do that again and stop it a little early. Okay. So this is our start position. Once again, this is very rough, just to demo this. So with the spline selected, we'll return to the hair system, Dynamics module, hair. Let's tear off this tab here. So with the spline selected, I'm going to select Set Start Position from Current. So now when we back up, we can see that our splines remain in this new pose, which is their new start position. Let's run the timeline, and they start solving from that point. So we can still see that we're getting a bit of penetration here. So we're going to go in and start adjusting some of the sim dynamic parameters here. And select the hair system and open the attribute editor. And then let's copy this tab so that we can deselect the hair system and still have the attribute editor selection. Now, this is a fairly quick and brief demo of the hair system, creating simple dynamic hairs. My hair is a very, not complicated, but a very deep piece of software here, a very deep component of the Maya Unlimited system here. And to do it justice would need to be covered in an entirely separate tutorial to cover all the different possibilities. And I've seen this used for ropes, for the follicle systems I've used to attach to deforming surfaces. I've experimented with using it for muscle systems, for skin, all types of things. It's an incredible system. So we're just barely scratching the surface here. And we're sticking with dynamic splines here because unless hair is a very important aspect of a character's performance, a part of the animation performance, so to speak, you know, creating dynamic hairs like this may suffice for your character. You know, once again, as we can see with this rest pose, you could go in and take the time to model a very specific rest pose, select the hairs, save that as the start position or the rest pose, but the start position in this case, and then use that with just standard dynamics, not needing to rig the hair. For a character like this, rigging the hair would be overkill. If you have a very complicated hair groom, for instance, if he had very short cropped hair on the sides and back, very bushy hair on the top, and a goatee, let's say, you could have separate hair systems for the distinct hair types. So you could use the global hair system settings rather than per follicle settings to get the dynamic behavior on different areas of the groom. So what we're going to do here is I'm going to open up the dynamics frame. First of all, set our iterations to 10. What this does is it allows the solver a higher level of precision. I make the hairs a little more stiff here. Let's try 0.5 just as a starting point. A little softer, 0.35. So next we have the stiffness scale. And what this ramp represents is are the stiffness values along the length of each of these curves. So I'm going to make it, and here we have a value of 1, which is 100%. So for the first 10% of the curve length, I'm going to have the stiffness at 100%. And then at the end, I'm going to raise the stiffness here to, let's say, 0.35. And this stiffness scale is sort of a ramp multiplier to the overall stiffness. So next I'm going to drop down to the collisions. And just as with the iterations, I'm going to increase the collide oversample, let's say to 10. And both of these changes, both changing the iterations as well as the collide oversample, will add more resolution, more granularity to the solve, more precision, but at the cost of slowing down the hair simulation. So what this will do is it will give us more precision with the collision solve. So move this over to the side. Let's see what we got here. So you can see the playback is quite a bit slower. So I can go in with this running and change some of these parameters. So there I just lowered the stiffness, get the hair to sort of droop back down. Once it starts colliding with the mesh, it will slow down significantly. We're getting a fairly decent solve here in terms of the amount of collision. Obviously, this is something that you would not want live in an animator's scene. You could have a hair system existing in the scene. Stop this for a second and rewind. But the hair system itself has global overrides. For instance, let's open the attribute editor. The simulation method, you can have it off or static. And so it won't solve, but the animator can get decent playback in their scene and just see the basic groom. And then you could have something in the GUI where once an animator wants to shoot out a daily or to see what their animation looks like with the hair dynamics, they can turn on the dynamics, start a simulation, go have lunch or a coffee, and then come back and see what it looks like. But you know, speed is a very important thing with these characters. So something we want to allow an animator to turn on and off in their scene. And also, this is just a very quick demo of just creating very simple dynamic hairs. Once again, you could go in and actually groom these splines and then set a new start pose, and you can have a very particular groom. go in here and just move some of these CVs. So you can have a very particular groom and have that as your rest position. Let's go in here and do a little mangled modeling on this. Thing you want to make sure of is that the CVs are not starting out penetrating into the surface. Okay, so I'm going to select these hairs once again. Hair. Set start position, and from current. So this is our new start position. So that hair starts from that position once again. So you could create very specific grooms for your character and just set the start position at whatever groom you've modeled with the splines. So once again, fairly brief demo of just simple dynamic curves. Once again, you know, if this character had a goatee and this mop of dreadlocks here, if he had hair coming out of his ears, and each of those can be a separate hair system that you can turn on and off at will. And also, you'd have a separate hair system for each, so you could go in and globally change each of the individual hair systems. You want to take caution not to have too many distinct hair systems. Trying to organize them as logically as possible, sharing whenever you can. Once again, a very powerful tool, and we're just scratching the surface here, just to give you a brief overview of dynamic splines here.